The extension of K means DB scan.
As in, it is also part of clustering.
K means is one method. Hierarchical clustering, is another method. DB scan is another method. 3 different methods I taught you yesterday.
Sir, magnifying சொல்றோம்ல சார், அது மட்டும் தான் சார் கொஞ்சம் கன்ஃபியூஷனா இருக்கு.
Magnifying lens, அதாவது அந்த ரவுண்டா இருக்கிறது I am not changing it. That epsilon size I am not changing. That's what I'm saying. So I keep scanning அப்படி பார்த்துட்டே போறேன். அதுக்குள்ள 4 வந்துடணும். That is the condition with which we wanted to build.
Okay,
4 பாயிண்ட் இருக்கணும். 3 பாயிண்ட் இருந்தா கிடையாது. அது அந்த பாயிண்ட் is a end point ஆயிடும் அப்படின்னு சொன்னது. Imagine what does that mean? So we are scanning the data. அதுக்கு ஸ்கேன் பண்றதுக்கு ஒரே சைஸ்ல எப்சிலான் சைஸ் சர்க்கிள் இருக்கு. அது நான் ஸ்கேனிங் magnifying glass. Scan is not about magnifying glass. It is about the epsilon sized circle that we are moving around. Within that there must be 4 points. It could be 3 points, could be 10 points, whatever. That is not well defined, right? It's just by nature of the problem. You will have to try different things and then you will say, oh, okay, this looks like a cluster. These are all outlying points, irrelevant points, noisy points. Bringing a control point.
Okay.
Does that make sense now?
Yes.
Don't think about magnifying glass. Magnifying glass mind la irukadhu. Epsilon da mind la irukano. And the magnifying glass, magnifying கூட சொல்ல வேண்டாம். அது என்ன ஒரு வார்த்தை வந்தது. I thought you will understand it. It is just a scanner. Round scanner. The round scanner diameter radius is epsilon units. So it could be 1 centimeter, 2 centimeters, doesn't matter, right? And I said in a multi-dimensional, this was a 2-dimensional points. If it is 8-dimensional point, it will be a sphere. If it is an 8-dimensional, it's an 8-dimensional sphere. Though you are talking about taking around a sphere and then seeing how many points are falling into place. என்ன அபி புரியுதுங்களா? புரியல. புரிஞ்சவங்க யாராவது எக்ஸ்பிளைன் பண்ண முடியுமா? இங்க யாருக்கு புரிஞ்சிருக்குது? பாலா
புரியுது சார். இப்போ சிம்பிளா சொல்லணும்னா, இப்போ நம்ம விண்டோஸ்லயே மேக்னிஃபையர் அப்படின்னு சொல்லிட்டு ஒரு டூல் இருக்கு சார். ஃபார் எக்ஸாம்பிள் மவுஸ் பாயிண்டர் எங்கேயாவது எடுத்துட்டு போனா அது பக்கத்துல இருக்கிற ஏரியாவை மாத்திரம் கொஞ்சம் பெருசா காட்டும். அது மாதிரி ஒரு இமேஜினேஷன் இங்க நம்ம வச்சுக்கணும். இட்ஸ் ஃபங்க்ஷன் இஸ் நாட் மேக்னிஃபையிங் but to find out the points which are falling under the criteria. என்ன கிரைட்டீரியானா 2. ஒன்னு அந்த எப்சிலான் டிஸ்டன்ஸ், இன்னொன்னு மினிமம் நம்பர் ஆஃப் பாயிண்ட்ஸ் இருக்கணும். இது 2 மாத்திரம் இருக்கணும். சோ இதுதான் என்னோட சேலஞ்ச். சோ இதை நான் மவுஸ் பாயிண்டர் அப்படியே நவுத்திக்கிட்டே போனேன்னா அந்த ஸ்பெசிபிக் செட் ஆஃப் பாயிண்ட்ஸ் இல்ல அந்த ஏரியால இப்ப லெஃப்ட் மோஸ்ட் இதுல வந்தேன்னா விண்டோஸ்ல வந்து ஸ்டார்ட் பட்டன் மாத்திரம் ரவுண்ட் பண்ணி பெருசா காமிக்கும், பக்கத்துல இருக்கிறதெல்லாம் இருக்காது. ஸோ அந்த மாதிரி இருக்கிற அந்த ஸ்கேனர் டீடைல்ஸை மாத்திரம் நான் இங்க கேப்சர் பண்ண முடியும். சில பேட்டர்ன்ஸுக்கு எனக்கு வந்து பிரிச்சு காமிக்குது அப்படிங்கிறதுக்காக இந்த டிபி ஸ்கேன் வச்சிருக்கோம். இதுல வந்து டென்ஸா இருக்கிற பேட்டர்ன்ஸ் இதனால ஐடென்டிஃபை பண்ண முடியல அப்படிங்கறது நேற்று பார்த்தோம். சில இடத்துல கேமீன்ஸுக்கு சில வகையான அட்வான்டேஜஸ் இருக்கிறத பார்த்தோம். டிபி ஸ்கேன் எந்தெந்த இடத்துல எல்லாம் தனியா பிரிச்சு கொடுக்க முடியும், எந்தெந்த இடத்துல முடியாதுன்ற அந்த இதையும் நேற்று பார்த்தோம்.
Excellent, excellent, very well said. இப்போ புரியுதுங்களா அபி? Okay, all right. Give me a moment because I remember I saw some very interesting DB scan article which is automated for visualization purposes, okay? And I want to show you how beautifully it works, okay? DB scan rings, pimple, uniform points. DB scan rings, I don't want that. Okay, this is cool. I'm going to show you some examples, okay? I think it is there as in other place also, but this is where I think I captured it. Few different examples I'm going to show. I have to share my screen. One moment, please. Okay, you'll be able to see my screen now. Tell me if you are able to see my screen. Okay? Yes.
Yes, sir. Yes, sir.
Yes, sir.
Okay, the data is like this. It's a smiley face data. Everybody gets it? Hmm?
Yes, sir.
Everybody gets it? Okay.
Sir.
And the epsilon is 1 unit. Whatever that 1 unit means, that means this circle. Minimum points, 4 points should be there. So what I'm going to tell you is that our method, see the epsilon reduces the size, right? The size of the circle. So let's keep it at 1. And then minimum point is 4. That's fixed, okay? So if I say go, what do you think is going to happen? Can somebody guess? Okay, you are not able to guess. What I would say is that no, all these things, this is, there are no points. This is going to drop out, 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 drop off. Drop off, 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 drop off. But this one, because 4 points is there, it will keep on moving. That is what I'm going to tell you, scanning. Okay, these are all will keep moving. Okay, and this will keep moving. So it will end up capturing everything other than this. Maybe this, the circle will, move around and then it will capture the eyes also. Can we try?
Yes, sir.
Yes, sir. Yes, sir.
This is what scanning means. I started here randomly and then it will capture that. The whole circle it will capture because it is, maybe here there is going to be a problem. I don't know. We'll see. Are you with me?
Sir.
Yes.
Now it is scanning. So it is scanning now. Okay.
Yes, yes. It's still scanning.
50% is scanned. Yeah.
பாத்தீங்களா outlying points ஆயிடுச்சு இதெல்லாம். Okay.
Right.
So it was still going around, right? So again it will capture. This is a different cluster. This is a different. That's all it says. This is a different cluster. 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 This cluster, I don't know whether it is able to capture 4 points. It's I don't think it is able to capture that point. So that is. Let me try one more time. I'm going to reduce the size 0.8 now. Are you with me? Let's see what happens. Everybody?
Yes, sir.
Yes.
I want this to go. This is a bigger size. I don't want bigger size. I'm supposed to have only 8. Restart. One. I am going to go to restart. I should have done this something else. We are going to compare this with K-means pretty soon, okay?
Yes, sir.
See, it stopped here. So randomly it started again somewhere. So how many clusters are there, you think? This is what the number of clusters means. Are you with me?
Yes, sir.
Excellent.
1, 3.
I reduced it 0.8. That's why you are increasing. Number of clusters are increasing. Do you agree? This is what we talked about yesterday.
Right.
So when I got 1, epsilon size 1, we didn't have that many clusters. We do have that, so many different clusters now. Okay. So the blue one, the previous one, when I had 1, was a different cluster. That's all. Because it has to start with a new random point because it doesn't connect. Right? Do you recall, the blue points here before when I had 1? Forgot.
Right.
Do you want me to do one more time? Same thing? But we have other examples also I want to show. Restart, sorry. Go. This is 1. Same points now. Oh, it's randomly redrew the points, So now it is part of the same cluster. Are you with me? It stopped. You guys understand what I'm saying?
Yes, sir.
This is a randomly reassigned point, so that's why I don't have a different structure and different cluster here. It's all part of the same cluster. Let's see what happens here. Because
Bottom portion, there might be something. Yes.
There might be, exactly. That's what I'm trying to predictively give you the information. Oh no, it happened joined through this way.
Yeah, it went through. Yeah.
But nonetheless, it doesn't include this one, so it's a separate cluster. It didn't include this one. This is a separate cluster. There are 4 clusters here.
Four clusters with epsilon 1. Yeah.
Epsilon 1. But remember, last time blue, that is because randomly selected distributed points. It just so happened there was a break there, so it ended up being a separate cluster here. We can try one more time, random collections, it might happen the same way. Now, I want to compare this. Let's compare this with the k-means, okay?
So the outer smiley is not the same, right? That's what you are trying to say. First thing is the outer smiley.
Resampled points, yes.
Resampled points. Got it.
For the resampled points, it's so k-means algorithm. Let's try it for this kind of resample again. Remember this is not exactly the same, but the shape of the cluster is good. Okay.
Yes.
So these are some add centroid. Okay, it starts with a centroid. I'm not sure about this points. Smiley. Add centroid, but then the whole thing became one cluster. K-means performance. These are our definitions. So that is random. I'm saying, this is my centroid. Let's say the whole point becomes, one cluster. I think that's what it means. See, if I do two, if I put 2 means, then these 2 will be 2 different clusters. Okay. If I put another 3rd point, then these are the 3 different clusters. In the case of k means. Let's visualize a little bit more about DB scan. DB scan is fascinating. Okay. Restart. I want, not this one. Restart. Density bars. Okay, let's do this one. Epsilon is 1, midpoint, minimum points is 4. Okay. It stopped here. 1 cluster. This is the 2nd cluster. This is what it means. Magnifying glass in பார்க்காதீங்க. Scanner னு பாருங்க. Prashant.
Yes, sir.
இப்போ புரியுதா?
புரியுது sir.
That's it. It stopped here. Well, it came through this way. Some extra point, 1 point Lamatic. Okay. And then there's another cluster. It stopped. Yellow stopped. Orange. That's it. These are all outline points. Orange. This is it. You see? In this structure, these are the clusters. Okay. Let's go back to another example. Uniform point density bar. Example here, I don't know what example here means. Okay, restart. Gaussian mixture. Okay, start. Hey, Gaussian mixture, go. It's going to be obviously three clusters here. Very clear, right? Very well, separated out. But this one is an outline point. Noise.
Right. All right.
There are 2 noise points here. There must be at least 1 noise points here, I think. Yeah. These are all noise points. Okay.
Right.
So, now it should be clear what I'm talking. Is everybody with me? Yes?
Yes, sir.
All right. Any other question before we go to continue the recommendation engine?
Sir, one question, like from our yesterday's discussion, we said like when we decrease the minimum number of points, cluster size increases.
Yes.
Like I didn't understand what a cluster size is.
Cluster size, you asked the same question yesterday. Cluster size means number of, there are two terminologies, number of clusters versus the cluster size, right? The number of cluster size will increase when your number of points is, what did you say? Number of points or epsilon size? Which one?
Two definitions, like one is epsilon, another one is minimum points. When epsilon decreases, number of clusters increases, which is a very obvious point, and we are able to understand that.
Okay.
The second, when minimum point decreases, like then we discuss like cluster size increases. So this is what I'm able to interpret.
So cluster size here refers to the size, the number of points inside the cluster. Okay. Let me go back to the previous, the scanner, the example I showed. Okay. Let me. Actually, it's. I wish she showed with the control on the number of points also. Okay, sign on this one. Okay, this one I was talking, right? So if I take a smiley face at the one, okay, minimum point is 4 in vechindrukom. If the minimum point is 3 in vechamanna, okay. If the minimum point is 3 in vechamanna, I cannot control. That's a problem. I wish I can demo that here. If minimum, given the same epsilon size, we are talking about the same epsilon size. In both the cases, we are fixing the other one. Okay, if epsilon is decreasing, given minimum number of points, number of clusters will increase.
Yes.
If minimum points is decreasing, given the same epsilon size, the cluster size will increase. That's all the conclusion, the statement was. Okay. So to see that, I can't control here, I may have to read, we may have to do some programming to show that, okay, I thought that that scanner will help here as an example. But you can see visually, I think we can see visually, So let me go. Oh, we did see an example, right? But yeah, I did see an example, but then I reduced the epsilon size, not the number of. I did reduce the epsilon size, but not the minimum points. That is the problem there. We don't have that example here. So what I would say is, think about it. Why it would be. The only way to do this is okay, let's go back to the optics example. Maybe from there I can share with you. Okay, the optics. What is the difference between DB scan and optics? Anybody?
Like it is ordered based on the epsilon in optics.
Yeah. So in optics, we are talking about the epsilon is controlled, right? Ordering points to identify clustering structure. So ordering points to identify the clustering structure is called optics. Okay. So what you are asking is, can you show me how or why, as the number of points given epsilon is fixed? If epsilon is fixed, okay, that's the question you have. If the minimum points is decreased, there will be a bigger, the size of the clusters will be bigger, okay, on an average. That's what we are trying to show. I don't think it will come through the optics. It won't come through optics. Okay, let us go back to this one, whether I can explain here. Let's see. Suppose I
will it decrease the number of clusters, sir? Then in that case, increasing cluster size seems to be meaningful for me. Like I'm able to interpret this way. Given one epsilon, if minimum point is decreasing, cluster size increases, but number of clusters decreases. Will that be a possibility?
Right. But because you are still keeping the same number of points, right? It can happen only that way.
Yes.
So let us. You said it. Well, let's see. See how it fits in here. For example, okay. Suppose I take only the 3.
Okay.
Not 4 points here. I take 3 points. Can somebody draw this graph? I'm not sure. Check it out in your. Okay, so here also I can say, for example, epsilon is 1 vachipon. This is epsilon is 1. Okay, epsilon is 1, and I'm asking for 3 points, 4 points, right? If I okay, so let me go back here. So forget about all these circles. I don't know whether you can forget about all these circles and then visually think only these points. And if I say only 3 points instead of 4 points, in this case we talked about 4 points. So what happens here? There are 4. Because the epsilon is the same. This contains 4 points. Minimum points. 4 points. This will be actually this won't work out. I think. If I do here, it is 4 points. If I do here, 2 points. If I do here, 2 points. 2. At least 2 points. At least 2 points. At least 2 points. At least 2 points. If I do this, at least 2 points. Okay, here is the example. If I say only minimum 2 points, the same epsilon size. What happens to this one? The clusters, yellows are not the endpoints. It's part of the cluster. Do you agree?
Minimum 3 points.
2 points. 2 points. Minimum 2 points.
So if the number of points is reduced, the cluster number will also get reduced in that case, right?
No.
Because they will all be. There is a heavy chance to get.
No, but you are not changing the epsilon. You are not changing the epsilon. Epsilon is same. The reason why this turned out to be the outlying point or endpoints is that because it didn't contain 4. It did not contain 4. See, this is the yellow circle. Only 2 points it contains. It contained this and this point only. But if I say minimum 2 points, this is part of the cluster. This is also part of the cluster. That's my point. So the cluster size increased. What was before, number of points was, did not include these 2 points, is part of the cluster now.
Okay. Yeah, the base cluster size is increasing, but the number of clusters will get decreased. If the number of points is decreased.
No, that is some extreme cases it can happen. That's what Arno was asking. Now I will modify that statement. In some extreme cases, it will happen that, it all depends on how the points are distributed, right? So we assume that, these 2 endpoints are considered as not part of the cluster, not part of the cluster. That's why we said, it can, if it increases, then it should reduce the number of clusters of it, right?
Right.
But in this case, the cluster is redefined. That includes these 2 points also, not considered anymore as endpoints.
Right.
Yes, sir.
Okay. Good. I think minimum 2 points explains that. I think you have to think about these possibilities. The only way to do this, visually, you take 2-dimensional points, draw in different ways, and see how it all, works out in the example that I showed you here as a DB scan, visualizing the DB scan. In this case, for example, I wish he gave control on the minimum points also. Then you will see exactly what's going on. So here I was showing you about the smiley face. How many clusters are there? If I have one, I think certain. But remember this redrawn again. I want to impress on you, Bala. These are all redrawn number pointers. It's not the same as the previous one.
Got it, sir. Yes, sir. Got it.
So this will be 4 clusters, but if we reduce the epsilon, it will increase the number of clusters. If I increase the epsilon, it will still have at least 3 clusters, because this is closer to this one. Maybe this will also get mixed up also. We'll see. We'll see what happens when I have epsilon equal to 2, for example.
Sure.
First epsilon minimum.
So there are 4 clusters now. Let us try the same smiley face with.
So similarly, we have another bar nearby. Does it vary the minimum points?
No, I'm sorry.
இப்போ நீங்க ஒரு scroll ஒன்னு பண்ணீங்கல்ல அது பக்கத்துல
minimum points control இல்ல. It's only the epsilon controls. Oh, here, wait. Okay, let's go back. I have a control here. One more.
That's what I'm asking.
This is 3. Let's make it as 3 points now.
Okay. That's what I was asking.
But the problem is the points are not the same previous points, but nonetheless, let's work it out.
அது ஒரே லைன்ல கொடுத்ததுனால ரெண்டும் ஓகே. I thought it's only for epsilon. Okay. Right side minimum points.
அது minimum points நீங்க போடுறதா நல்லா இருக்கும். epsilon நீங்க போடுறதா நல்லா இருக்கும். But anyway, we learned. This will not show much, and separation is already higher, so this is not a good example. Let me go back to another one. Everybody agrees separation is already clear, so I don't want to use this one. How about this one? Pack circle. This is better. Okay, so let's start with the epsilon 1 minimum 0.4. Let's see what happens, and then we'll reduce the minimum point to 3 or 2. What happens? Okay, 2 clusters are there right now, and these 2 clusters are there. These 4 points are not included, right? Let us see what happens if I reduce the. Oh my goodness, I changed it because I had to change. Then I had to restart, and when I read it, it will resample. Okay, so I don't know what happens. Let's see. Anyway, 3 points, minimum 3 points. Okay, we saw only 2 clusters with 4 outline points. Am I right? Remember that?
Yes, sir.
Yes, sir.
Now I reduced it to 3 points.
Okay.
So when I reduce keep the epsilon same and increase, reduce the minimum points. What happens? What is the conclusion? Cluster size increases and so on. Cluster size increases. There is a difficulty though. We need to keep the same points. That is not possible in this demo. That's an issue. So here also 2 clusters, but the kind I don't know whether you can recall that this cluster size is much bigger than the previous one. There are only 2 points that are left out here.
Yes.
Okay. But there is some small difficulty here because this is not the same point that we are, as far as I know, it's not the same point, because that's the reason I know why it gets different results when I restart. Okay. For example, let's remember that, there are 2 points here, just, like 5 points and 2 points here. Let's see whether, when I restart it, redraws the same point. Okay. No, do you see this one? I don't see that.
No. Changing.
So I cannot really use this demo point, let's do 2. Ready?
Yes, sir.
Does anybody know how to do GIF? This is called GIF file. Do anybody know how to create GIF files? No? No? All right. You have to know how to create GIF files. It's very important because you can dazzle people with this kind of stuff. It's going to create 2 or 1, I don't know, or 2 right now. Okay. Minimum points 2 potaka with the same, cluster size increased. Some cluster size increases. It also increased actually it increased the number of clusters also. Are you with me?
Yes, sir.
So that is a better statement. I mean, some clusters will increase, but there is no one simple rule that always that's the only statement true. That's how I see it. This may be a better example. Let's see. These are 4 points. And distributed points you can also. This point turned out to be an end point, outline point. Oh, it did come through this way. Okay. Now 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 clusters. These are outline points. But the problem is, if I start this will redistribute, I cannot really prove much. But let's try with 3 points. Okay.
4 to 8 and 4 to 8 and distributor function.
This stopped here, this stopped. Oh, it did capture this one. So it's going to capture, I guess. Yes, it did. Yes, it did. This is going to come back. Because I'm not asking more points to satisfy. If I ask more points, that won't be part of the cluster. Okay, this is going to be this is going to be a separate cluster. Nonetheless, 1, 2, 3, 4, 5, 6, 7. Agreed? Because this size increased.
Yeah.
So, but we had to be a little bit careful. It depends on the distribution of the data points, right?
Yes.
What would be an outlying point will become part of the cluster if the minimum points is reduced. So it may not reduce the number of clusters, but it's because you are requesting less number of points to satisfy within the scanner, within the epsilon size, a circle in a 2-dimensional space. the cluster size will increase. Possibly it will still retain the same number of clusters. Okay. For example, if I had இது ஏன் வந்து 2 பாயிண்ட் தானே கேட்டேன், இது போட்டா இது ரெண்டுத்தையும் வந்துருக்கலாமே. 3 points. Oh, இப்போ ஒரு எக்ஸ்ட்ரா பாயிண்ட் இங்க இருந்துன்னு வச்சுங்க, this will be one cluster, right?
Right.
So கொஞ்சம் extra details are there, Aruna, if that's what is holding us. Yes, I agree with you.
Yes, I understood. It's not literally the same term. Like cluster size increases is not exactly applicable for all the scenarios. Few clusters may increase in size, few clusters may retain its size or decrease. And number of clusters may not decrease.
So the keyword to add is now in general, you can say this.
Okay.
It doesn't mean absolutely. It's a simple rule. It's in general true. Okay.
Yeah. Okay, sir. Got it. Thank you.
Good. All right. Any other question from yesterday? Yesterday class was very, very important. Cluster methods is fundamentally very, very powerful, important data science projects. Clustering. Dimensionality reduction is fundamental problem. So these are all very, very important. Now yesterday we also started talking about recommendation engine. Very fundamental. Okay. So any questions? And if not, then we will move to the recommendation engine. Continue. Any questions? Ready to go to the next topic? Continue with that topic.
Yes, sir.
Okay, cool. All right, we started with the movie rating. Are you able to see my screen? Movie data set for analysis has 4 tables. I used all these commands. And then the movies have movie ID, title, genre. Ratings have movie ID, rating, timestamp. Links have movie ID, IMDb ID, tomato database ID. And then tags are user ID, movie ID, tag, timestamp. Okay, these are the variables we have. Everybody?
Yes, sir.
And we want to convert these tables into one table to answer the following question. A person who has given rating about a movie wants to know, are there other similar movies, right? You give, let's say I like action movie. I want to know, are there action movies? It's a very common problem I go through. I don't know whether you go through. I mean, I see a lot of Netflix. Enga sir ungalku time irukku kekringla? I find time. And it's not healthy. I see a lot. Especially after Netflix came, I see a lot more movies. I don't have time to go and sit before the TV, but I can lie down and watch and so on. Okay. The point is, I like sometimes suddenly I will start liking feature films, or suddenly I will start liking, animals, something like that, right? So I'm always looking for, are there similar movies? That's exactly what the question here is. Are there other similar movies that others have voted thumbs up? These kinds of questions are interesting from my personal point of view. In all these cases, meaning of similarity needs to be defined. Agreed? Similarity is what defines these kinds of answers. Be creative on what goes into the similarity definition. We talked about, we kind of entered into it, but we are going to do more about it. Okay. So users with similar ratings on anything will have similar interest in the basket of items, which may not have been rated by either one of them through the commonness of the basket that is being evaluated for recommendation. What does this mean? Do you understand what I'm saying? Users with similar ratings on anything will have similar interest in the basket of item. Or basket of item Abhi says, oh, I like this, I like this, I like this, I like this. Out of 10 items, she says 5 items. Okay. And then Aruna says, I like this, I like this, I like this, I like this. So now 7 items she says what she likes. If your liking is more common than Durga's liking, if both of you have more common liking, then each of you are more likely to see whatever you voted up, right? Like Aruna will like, most likely will like this, the things that Abhi rated high versus compared to Durga. That is the point you are saying. Okay, am I making sense or just giving you just words? And we saw that in all these things, started seeing that. Now, so let's do the programming. And I started viewing the movies like this. After I read the data set. View movies means comes out to be like this. There is a pipe here. There is a comedy, pipe, drama, pipe, romance. Okay, this is the genre. And then view tags. Brad Pitt is Brad Pitt is a key tag there for movie 212. I think it's a movie tag. Tags first and or the tag user ID, movie ID second. Yeah. So 212 movie 212 is acted by Brad Pitt because it's an actor related issue. This is breathtaking. So it's a tag, okay? And then ratings are here. Movie ID 1 is rated by user 7 as 3, 4 and 5. Anything above 4 and 5 you can say really good, okay? Rated as good. Anything less than that you can say not so or not good. Well, we are going to define that kind of binary separation so that we can solve the problem. Okay, you don't have to have the binary separation, but that's one of the ways. Okay, because when you have a binary separation, it becomes a lot more clearer. If you have 1, 2, 3, 4, 5, then 3 is should we add with the 4 and 5 or not? That question is also there, still there, open there, and so let's make a hard decision. 4 and 5 is considered as good. 1 to 3 is considered as not good. That definition separates out very clearly, good versus not good. But if you put 1, 2, 3, 4, 5, there is still a problem of you can only estimate the average, but not good or not good issue. Okay, it may turn out to be 4.2, 3.5, 2.8, and so on when you predict the score for a movie. So this is the setup with which we started yesterday. Are you with me so far?
Yes, sir.
Okay, so using the genre, there are, I think, 18 genres. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 genre varieties for each movie. You can code them because because the movie has that information with pipes. Agree with me?
Yes, sir.
Yes.
When it is there, you put a 1. When it is not there, you put a 0. That's what this data set means. And we are going to create that data set. Okay. So this is genre information. Okay. Make the matrix of characters as strict integers. The dimension is 9,125 movies by 18 genre matrix 3 contains rating for from 9,066 movies only out of 9,125 because there are some movies were not rated at all by 671 users. Okay, we are going to drop some of those movies for which we don't have any rating, totally no rating at all. Okay, are you with me so far? And I'm setting up the problem for you. I'm also walking you through the logical step. Okay. All right. So with that, let's go ahead and do the. Well, let me explain a few more steps because you are going to be otherwise, maybe because if you keep on doing just the programming, it might be confusing. Okay, so let's do this. This is genre information. Every movie has 0 or 1 depending upon what the movie. This is Toy Story. It is adventure, animation, children, but not action. It's not crime. It's not documentary. It's not drama. It is fantasy. It's not film noir. It's not horror. It's not musical. It's not mystery. It's not romance. It's not sci-fi. It's not thriller. It's not war. It's not western. That's what this means. Okay. So now let us say. So I'm going to do the binary ratings for the movies. Original ratings and the binary ratings, and I convert பண்ண போறேன். Then I'm going to do some similarity calculations. Okay, what similarity calculation I'm going to do? These are the similarity calculations that I'm going to do are made up of this structure. Okay, so I have 18 genres. Look at this one, 18 genres. With the results on liking or not liking, binary scoring based on 671 people. For 18 genre, this is genre 1 profile, second profile, 18th profile. Okay, so each row is a one genre, and then each column is one of the person's ratings. That is what I'm going to eventually get to. Okay, everybody understands where I am going? This is what I need. because this is, I am separating out, this is basically saying item based scoring. I didn't explain this to you before. I was initially introducing user based scoring. U1, U2, U3, U6. You remember that? User based scoring. But now, in order to do the item based scoring, I need the features of the items. In this case, genre. I need features of the items, in this case, genre. And that is what these 18 genres are scored by 671 people, and those scores are converted into binary scores. And that's what I'm going to get to. And using that, I'm going to create a similarity matrix. Are you with me? Similarity matrix from this data. So for each genre, column of genre matrix 3, that's something called genre matrix 3. I'm going to show it to you how I did that by taking inner product of 9066 movie first genre with 9066 of each of the user ratings. Remember, first genre, okay, 9066 movie first genre, inner product of 9066 line items. 9066 movies are there, right? So adanoda data with 9066 of each of the user ratings, and summing them over, we get how many times the first genre is preferred. Does that make sense to you? How many times your user one will like a first genre is taking the inner product of 966 movie first genre with the user ratings of the first person of that particular movie, user rating of the first particular movie. So in this case, first movie. The higher the number, the more liking it is for that genre. Are you with me? Koncham confused, but you will be fine. We will repeat a few times, then you will be fine. The output will become 18 by 671. That's what this is. How do I get this 18 rows 671? It's coming out of this. Then the result 1 means user profile, and result dot comma 1 means genre profile. In this result, in this one, this is user profile, and this becomes genre profile. That is the definition we use. The genre profile means this column wise, row is user profile. Okay, let's do calculations, and then we'll come to appreciate all these recall of ideas. Okay, recommend the genre that has least distance from the top row added with the 18 rows in the result matrix. So I'm going to go back to R and start showing you that result. Okay, let me go to R. So remember, why you got to ask the question, why is that I'm taking the inner product? So that I can find out which genre is more closer to the individual, and what he likes, he or she likes. Accordingly, the recommendations will come through the genre information. Right? When I watch a movie and then I'm searching for another movie of the same type, I'm looking for genre related information. Okay? Does that make sense to you? Action, animals, right? Like that. Okay. So let me redo this. I closed it yesterday. So all these things are run. The data set is available. I think you asked this question. This data set is available. I want to know whether it's available in the PA2 class notes. Where am I reading? Oh, I'm reading it from users downloads. Oh, okay. It's in the download section. Okay, what I will do is now I can compress this and post it. Okay. Users downloads, right? So okay. So these are the data sets. Okay. So what I can do is, I think I always give this. Let me see. There must be a zip file. Can you change zip file? This is not zip file. I thought I zipped it, right? What happened? It should be here somewhere. I thought I did it, right? So let me try one more time. ML latest small zip. Here it is. Okay, what is the size? It's not too big. It's less than 1 megabyte. Okay, so I will put it in the announcement section. If you can download and I'll also put this program. Okay. Okay, now I have to go to instruction, announcement section. Movie dataset and R program reports. Recommendation. Where is recommendation? Starts with recommendation. I have to include this file also, SVD image example. I said I'll give that.
Similar like ரெண்டு பேரோட இன்ட்ரெஸ்ட் சிமிலரா இருக்கலாம்.
Oh, it is not in this one. Okay. I think I know where the issue is. Okay, this is file save. I can see where it is saved as. It's in PA2 recommendation.engine.org, and that's what I thought. Maybe I didn't see it. Okay, here it should be. Okay, here it is. Okay. Let us see. Let's see. I thought it should know. It doesn't take that way. I can do this way though. I can attach files here. PA2 recommendation. The other one is I can attach one at a time. Okay. Only one file at a time. Okay, you know what I'll do? I will pack this one into this. As new file. Just give me a moment, please. Sorry, it is taking time. So I went to downloads data. Okay. So okay, I'll put it here. This one, copy, print here, paste. So I'm going to zip everything now. Redo the zipping again. Now I attach this one, okay? At I browse. It has to be with downloads. That's it. Okay. So I announced it as part of an announcement, the file as well as the program. Okay. Now let's go back and do this, and you can take a look at it later on. So we do the structure, what is going on in terms of the data, and then I start parsing the genre, so that I can write that 011 file. Do you remember I talked about? There's a maximum of 7 genre per movie, but then all movies put together there is going to be 18. Okay. How do I know that? Only by looking at the data. Okay. Correct? Right? All right. Okay. And then I'm giving a column names to this genre. There are these 18 names that I know. Okay. And then I'm creating a genre matrix. Ethna column genre matrix 18 I told you, right? Agreed?
Yes, sir.
But I'm initializing it with 0, and then I will overwrite on that. First I need to set up a matrix in which I will write, and there must be 9,126 rows should be there. Agreed?
That is my question. Yes, sir.
Everybody, you have to say yes or no. And then I'll set the genre list name for the first row. That's what I'm doing here. First row is genre list name. I can also call it as column names, right? Genre list as column names. I'm running all these things. I'm setting up the data now. So what am I doing here? I iterate through the data to post. To post one wherever it is, the genre is available. Otherwise, I just leave it. I skip that one. So everything is filled up with 0. Wherever that particular for a particular movie, a particular genre is there, it will be posted as 1. Are you with me? Yes. Do you agree what I'm saying? I mean, do you understand what I'm saying?
Yes, sir.
Yeah. Now, in the data where we need to create this data before I do the inner product calculation. What data I have to create? Let me see. This one. I need to create this 01 genre information. 0 or 1. If the particular genre is there, I have to code it as 1. If it's not there, I will leave it as it is. So first I create everything as 0, and then put one wherever it is happens. I put 1. That is what is happening with this code. For I in row 1 to n row, and for C in 1 to n column, I create genre matrix column by column I'm creating. Okay. Genre matrix 1 comma space is taking data from genre 2. This one, genre 2 is what? This is basically I split the genres by the pipe. That's what the TSTR split function does. Okay, and then I'm writing it as a data frame into genre 2. Genre 2 is whatever the data is split to. You want to see genre 2? We can see genre 2 if you want. So I think kind of do you see this one? First genre is 1, 2, 3, 4, 5. Idella not available. Okay. There are, you can give maximum of 7, but in this case they have given only 5. Idella correct. Let's go down. There are some genres that are coming later. Wait a minute. Oh, There are maximum of 7 தான் இருக்க முடியும் இல்லையா? 7, 8, 9, 10. I have created a holding place up to 10, but maximum is going to be 7. But the thing is, doesn't mean that no comedy is only here. Remember that. Okay, comedy in the படத்துக்கு 4வது comedy வருது. But here the 4வது 20 for movie 20, 4th genre item is drama. For movie 22, 4th genre item is mystery. It's all mixed up, but I'm just pipe with using the pipe separator. I just separated out all these items. Okay. All right. Now let's go back to this program. And Bala, how is it going?
எஸ் சார், புரியுது சார். இந்த இடத்துல ஒரு மூவிக்கு மேக்ஸிமம் 7 ஜான்ரஸ் வரைக்கும் இருக்கலாம் அப்படிங்கறது நம்ம ப்ரோக்ராம்ல எடுத்துறோம். சோ அந்த டேட்டா காமிச்சிருக்கீங்க. So there are totally 18 genres available.
Yes, exactly. And we are just in this step genre 2 I just split வேற ஒண்ணும் இல்ல. And then I told you I created a matrix of zeros. அதை போய் நான் fill up பண்றேன். Wherever that particular genre is, now I am making it column by column. A column means a specific genre. Earlier it was not. Agreed? Everybody? Okay. So column names எல்லாம் பண்ணிட்டேன் நான். Okay. பண்ணிட்டேன்.
39.
I'm sorry, can you repeat?
Line number 31 and the matrix empty matrix create பண்ணினப்போ number of rows வந்து 9126 னு போட்டுருக்கோமே. நமக்கு actually 9125 தானே movies.
Let's see how many movies are there. Okay.
Yeah, total number actually we are dropping some movies because
later we will drop. Later we will drop.
Oh, okay. Oh.
Movies movies. Okay, end row should work, right?
9125.
9125. Okay. Movies. 9125. Okay. Yeah. Let's see. I'm not sure why I put 9126. Okay. You remember the one of the first row I wrote as the genre. I introduced genre names there in the first, because for some calculations later on that is easier. Okay. Maybe it can be simplified. For now, let us go back. Let's see what I have on the movies. To one moment. I have come too far. Okay. So genre matrix, one என்னன்னு பார்க்கலாமா? Matrix. It's a matrix now, right? I want to know first row. Okay. So the first row is not data, it is just the column names. That's the reason why it is 9126.
Okay, sir.
Now up to 34 we have done. Now what am I doing? I play this after 37 to 42. I placed 1 all over wherever that particular genre column happens. Let's do that. It's done, and it's doing right now because it's a huge calculation. It's done. So what should I see in output here is genre matrix now.
Under each genre as column name, we will be seeing one or zeros based on the movie type, right?
Yes. So பார்க்கலாம். First row என்ன நடக்குது, and then second row ரெண்டு பார்க்க வேண்டியிருக்கும் maybe. First row is names as expected now. So the first is Toy Story. You remember? It put 1 there. Animation, children, comedy. These are all. It's not crime, not documentary, not drama. It's a fantasy. That's why I'm all 0. So that's exactly what has happened here for every one of the movies. Okay. Now I need to convert this into a data frame, because data frame is the way to do calculations. Okay. I'm creating a genre matrix into a data frame now. It's done. And then I'm keeping the data as integers. Okay. Right. Now let's see what is there in after all these things are done. So this is right. So now it's basically all these numbers that we have. So I can do some mathematical calculation. What kind of calculation I do? I'm going to calculate some kind of a cosine and some kind of a similarity. For that, I need this kind of data matrix. So I created the genre information into a data matrix. Okay. Then I need to do some calculation about the ratings. This is only about genre. Now I need to do some ratings conversion. So whenever it is greater than 3, that means 4 and 5. If it is 4 and 5, I will make it as 1. If it is 1 to 3, I will make it as -1. Like versus not like, that kind of information. Agree?
Okay. Yes, sir.
Okay.
But any specific reason for making it as -1 instead of 0?
-1 versus 1 is a better separator. 0 is, in terms of separation, -1 is a better separation than 0.
Okay.
Yeah, it is, I can say this, slightly with the English word also, right? Do you like it? No. Instead of that, if I say I don't like it, there is a difference, right?
Okay. Yes, I agree.
So let's run this one. It's still running. Because there's a huge calculation to do, right? 9,000 rows versus 671 columns, something. So you need to keep thinking about, what is the structure of the analysis, we are thinking, okay? Keep thinking about that. What is the structure of the analysis? It's still working. Okay, it's done. So let's just do what is there, five rows. Okay, let's see. So it basically converted, because it is 100,000 plus, right, ratings. For each of the movie, each of the rating is converted to -1 + 1. That's all we did right now. Are you with me? What is the dimension? You expected this, am I right? Because there was 100,004 ratings were available for us. Okay, each line is 1 rating. So, in order to get so I need to do, what is called the, casting the data. So I need to do some casting the data in a way that I can do the inner product. This is given to you 1 rating per person, per movie. But I cannot use it as it is, but I need to cast this data into a certain reshape. This needs to be reshaped so that I can do some inner product calculations. Okay. So far, are you with me? Recasting the data, reshaping the data I'm going to do. Do you agree that I need to do some reshaping? I don't know what it is, but I need to do some reshaping if I want to combine this with the genre information. Agree? And you will know what kind of reshaping I'm going to do. So there is something called a package called dcast. Okay. So I take the package dcast. It should be loaded. Let's see if it doesn't work. I think it's part of it now. So I'm take the binary ratings, movie ID, movie ID values dot variable rating. NA is, don't remove the NAs. And for I in 1 to column, N column, binary, I take the binary ratings. This is what the actual action is happening. I take the binary ratings, and then whenever it is not missing, whenever it is missing, Whenever it is missing, I put 0. Otherwise, I write the 1 or minus 1. Are you with me? Into a matrix type form. Okay. So, okay, one more time. I take the binary ratings. Okay. First of all, I need to do the decast. Let me do the decast. Okay. And I'm taking the data from the decast. Binary ratings too. Right now I got binary ratings. I need to do the binary ratings too. Let's do that first. Okay, it's done. So can we just check what it is? Maybe view binary ratings too. So the binary ratings too is cast into a matrix like this. It was not before like that. Do you understand what I'm saying now? Wherever it is NA, where it's not there, it's not there. Whenever it is there, whether it is -1 or +1. Understood? For every movie ID, I have this information. So how many I should expect? What is the dimension of binary ratings? You think? Somebody? Huh?
Same as binary rating.
Yeah, same as binary rating. But how many do you think you should have? Now, 9,066, because for some movies we don't have anything. So those are dropped. Okay. So let me go back. So is that clear to you? I have rating for every movie, wherever it is rating, I'm retaining. Rest of them are not used because I can't use that information at all. Okay. Now I take that data, and then whenever it is missing, I'm making it 0. That's all I'm doing. Because it is 0, 0 you want to make it into 0. Do you agree with? Do you understand what I'm saying? That's all I'm trying to do now. Oh, what did I do? Control Z, Control V. It's done very fast. Now let us see binary ratings. You see, I don't even have to review. When I clicked on it, it is recalling the latest data in binary ratings too, which introduced zeros all over. So now I can do mathematical calculation. That's the reason why I did all these things so far. Okay, agreed so far? You all agree?
Sir, இப்போ ரேட் வந்து இப்ப நம்ம ஜீரோ செட் பண்ணது யூசர்ஸ் வந்து ஒரு இதுக்கெல்லாம் ரேட்டிங் கொடுக்காம இருந்திருப்பாங்க, அதைதான் இப்ப நம்ம ஜீரோன்னு செட் பண்றோமா?
Whatever for every movie, there is a rating available. Okay, for every movie rating is available. Only 9,000. Not every movie. I'm sorry. Wherever the movies have ratings available, which is 9,066, not 9,125. We convert them into data set, matrix data set here. Okay, because that's the only way to calculate the inner products, the cosine similarity, all those things. Okay. So, but when we do that, we also introduced from 1 to 5, we introduced a binary ratings scale instead of 1 to 5. Okay. Do you like it or I don't like it? Something like that. Okay. And that's what this conversion has done so far. So for every movie, I have the data information. That is, whether in this case, let's see. Okay, let me do the n column. So there are 672 people who rated the movie, each of these movies, right? That's what this is. Each of the column refers to first guy, whatever the ratings he gave for all these 9,066 movies. Are you with me?
Sir, 671 users தானே நம்ம இவ்வளவு நேரம் பார்த்தோம். 672
movie ID is the first column. We keep the movie ID. We keep the movie ID. Okay. You see this one.
ஜீரோ நான் செட் பண்ண கேள்விப்பட்டேன்னா, இப்போ ஒரு மூவி எடுத்துக்கிட்டா 671 யூசர்ஸும் வந்து அந்த மூவிக்கு ரேட் பண்ணிருக்க மாட்டாங்க. சோ அவங்க ரேட் பண்ண எந்த யூசர்ஸ் எல்லாம் பண்ணலையோ அங்கதான் எண்ணெய்னு இருந்தது. அந்த எண்ணெய் வந்து இப்ப நம்ம ஜீரோன்னு போட்டிருக்கோம்.
It's possible all the 671 people ranked and rated the movie 87. It's possible. but theoretically
Yes.
possible, but does it happen that way? I doubt it. Okay. For example, movie 1 is rated by user 7, user 9, user 13, user 15, user 19, user 20,
Yes.
23, 26, like that, 30, 37, 43, 44, like that. Okay, there are 671 columns here after the movie ID. Is that clear now?
எஸ் சார். இப்போ அவங்க மிச்ச யூசர்ஸ்லாம் வந்து மூவி வந்துட்டு அவங்க ரேட்டிங் பண்ணல, அதனால எண்ணெயில் இருந்தது. அந்த எண்ணெயில் ஜீரோன்னு ரீப்ளேஸ் பண்றது வந்து தப்பான இன்டர்பிரேஷன் கொடுக்காது. அதாவது அவங்க லைக்கும் பண்ணல, நாட் லைக்கும் பண்ணல.
If you remember, you face the same situation when you are doing the calculation, some product calculation. Whenever it is missing, it's not going to count. That's what is going to happen. It's explicitly stated here. You remember that? You actually asked that question also. Oh, it's not using that information. Some product போடும்போது whenever it is missing, question mark இருந்ததுன்னா it's not going to use that. அடுத்த காலத்துல டேட்டா இருந்தா கூட ஒரு காலத்துல வந்து question mark இருந்ததுன்னா that is going to be not used. Do you remember that in the sixth?
Question mark தான் இருந்தது, but இங்க ஜீரோன்னு ஒரு வேல்யூ.
Yeah, question mark is same as not available here. We don't know. That's what it is. Zero means here we don't know.
Okay.
Okay. It makes it certain calculations explicitly valid. அது வந்து Excel la வந்து some product will be okay, but here we don't know, so we just make sure that it's all defined as zero in R.
Okay. Okay.
So we saw up to this, we know binary ratings 2 has 9066, 672, all these things are fine. Remove rows that are not rated from movies. It's already, I thought, how did you lose it? Did I lose it somewhere here? Genre 3 on it now. Yes. Okay, let's just do that. I need to remove the movies list. See, there are now two data sets. Binary ratings 2, and then I have movies data set, right? So I'm going to remove the wherever the movie ID is not there. Okay, let's remove the movie IDs. First of all, find out the movie IDs that are unique, and then find out the rating movie IDs. How many of them? It should be similar to what we saw earlier, but let's see. I also want to know. Okay, let me just do up to this, and then we will remove the row names null, resetting the index with the 1 to row num. Okay, row names movies 2. What is the movies 2 on the row names? Row names are movie 2. Currently, what is it? This is what the numbers are given to us. These numbers are omitted 86. Okay, these are the row names. Row names are just the movie IDs. You remember that's the one you were also talking about. We are removing that basically now after all these things are done. Okay, you see this one? Row names are movie IDs. Actually, we remove that because when you do the mathematical calculation again, that's going to be that can be an hindrance. To use formula in a systematic way. So I'm going to make that as a null. That means removing it. Okay. I think I can select and run from here to rerun the previous code. Source the contents of the active document. Run the current selection. I think it will work. Yeah, that's good. Now I'm creating another matrix. Whenever the movie ID is in the rating movie IDs. When it is not in the rating movie IDs, I remove them. Minus which. So do you see what I'm saying? Minus which condition, which, and then minus that. I'm removing that. Run this. Before we go to matrix genre matrix 3, let's just understand genre matrix 2, and then maybe you will be predictively understand what is going on with genre matrix 3, right? This is genre matrix 2 is 9125 18. Okay, this is just a genre information. Everybody?
Yes, sir.
Now, with this, what do you think is going to happen? Just guess it, because predictively we have to understand that's what it means to say we know. Somebody? I'm the commented. See, there are two data sets right now I'm working with. That is genre information, and the other one is rating information. Everybody?
Yes.
I have rating information for 9,666 movies, right? We know that. Binary ratings too, 9,066 movies.
All right.
And that should be reflected here also. That's exactly what I'm trying to do. Now, is it okay? You can understand? Okay. Enna Aruna correctங்களா?
Yes, sir.
Abhi,
Yes, sir.
Prashant,
Yes, sir.
Srivats, cool, very cool. Srivats? Okay, it's done. Now I want to, okay, so let's see what is the dimension of, what do you think dimension of genre matrix 3? Anybody?
9066 by 18.
It's correct. But it makes sense, right? We need to bring them same because by movie by movie, we need to take the inner product of the genre information with the rating information. That's what we are going to do. Okay. Okay. And then I'm going to replace what is right now. What are the row names of genre 3? Bala? Genre matrix 3. What do you think is the row names? I'm just going to remove them later, like what I did with ratings. I'm going to do that also. Remove that too. Okay.
Yeah.
Is there
action அந்த genre names வரப்போகுது இல்லையா?
இது வந்து because it's it's remember it's a movie, right? Movie IDs. So 9,066 movie IDs are there. So I'm going to remove that, nullify it, so that I can do calculations systematically. I can do the calculations.
Okay. Yeah. No, these are row names. Okay.
Yeah. Row names. Yeah. So we need to do that. Run that. Genre matrix 3 is done, right? Which okay. Then now I got the result. Calculate the dot product for user profile, measures of user specific liking for that particular genre, right? And store it in results variable. You remember I talked about the results matrix in the presentation? That is right now, before I create the results matrix, I'm setting up to be 0 all over, and then I calculate the inner product, the sum of the inner product of the genre matrix 3, which is the genre information, and then ratings information. Okay, column by column, I'm calculating this. Are you with me with these codes? First, I'm setting up a huge matrix of zeros, and then I am filling up the values with this inner product. This is called inner product. Sum of the product. This is the product, right? Product information of genre information versus rating information. Now, when I put genre matrix 3 column I, what is the size of this vector?
9066.
Yes, perfect. And what is so inner product should have the same size here also, right? Binary ratings 2. What is the column of the binary ratings 2? Do you remember binary ratings 2? If you forgot it. It should be compatible multiplication, right? That's all I'm trying to say. Dimensions, binary ratings 2. You see, that column is also 966. Now it makes this is a compatible inner product. Everybody agrees?
9066.
The dimension of genre matrix 3 கொஞ்சம் print பண்ணுங்க சார்.
Genre matrix 3 என்ன சொல்லணும்?
ஆமா, dim of genre matrix 3.
Okay, fine.
Genre matrix.
Okay.
This is how you can get a results matrix. of 18
Right.
rows and 671 columns.
Right.
Or 671 rows, 18 columns, depending upon how I multiply. You have to understand this part because this is a critical step, milestone in thinking. This way, all my correct ratings are identified with respect to a specific genre, which is very, very important in in identifying what genre matters to me. Right? I have given a rating, and with that particular genre information, now I am more and more specific. There's some product, inner product information, which is a cosine, part of the cosine similarity information. Part of the cosine similarity information is giving me the weights that are relevant for me. Everybody with me? Abhi? Huh? Correct? Purida? Very good. Durga? Everybody? Prashant, Shrivats? This is a milestone understanding, you know. So what is the output I will get? What is the dimension of the output file? Right? 18 rows, 671 columns. Everybody with me?
18 rows. Yes, sir.
I want to see you all. Bala.
இல்ல சார் அந்த மேட்ரிக்ஸ் மல்டிப்ளிகேஷன்ல ட்ரை பண்ணிட்டு இருந்தா அது அந்த ரூல்குள்ள இது வரலையேன்னு யோசனை பண்ணிட்டு இருந்தேன் சார்.
அது எப்படி இது பாருங்க, இது உங்களுக்கு வந்து ரிசல்ட்டே இவ்வளவுதான் டிஃபைன் பண்ணியாச்சு. ரிசல்ட்ல தானே போய் எழுதுறேன் நானு. How I am filling up each one from genre and binary ratingsல இருந்து how I am filling up ன்றதுதான் இப்போ issue. அது வந்து that's a dot product. I need the dot product because it is going to give me where the most positives versus negatives are given here and with respect to what genre.
Okay.
Correct or not?
Understand பண்ணிருக்கேன்.
Okay. Sorry. But it's a very important step. இது புரிஞ்சுக்கணும் நீங்க. ஏன் நான் வந்து inner product எடுக்கிறேன் because that's going to be part of the similarity measure that we are going to talk about later. And why this matters? Because this is what matters for each of the individuals. They are weighted by genre information. The liking is weighted by genre information. That's exactly what is going on there. The liking is weighted by, personal liking is weighted by the product, what kind of products I buy in general, or what kind of movies I watch, what kind of web pages I search. This can be used in web search, information retrieval, website optimization, personalization of website optimization, product information, movies, all kinds of things, recommendation engine, wherever it's used, this is what you need. Liking weighted by the, instead of genre, you're going to see the product, you're going to see the movies, you're going to movie types, you're going to see the product, you're going to say the website, you're going to say the keywords you use. Okay?
Okay.
Are we ready? Can we move? Yes? How about you think I'll give you 1 minute. 1 more minute.
Sir, ஒரு நிமிஷம் binary
All right. Now, what is the question?
binary தடவை view காட்ட முடியுமா சார்?
This one?
Yes sir.
9066
The whole column in binary rating says cross product. Create a cross product with the whole column in genre matrix, because it has to be run through the movies. Movies is your moving index. So that's why the result will be 18 by 671. Correct?
அந்த ஹோல்க்கு தான் சம் போட்டுருக்கோமா? ஓகே.
Hello? So do you think you can take this coding method, solution method, apply it for a retail company? Retail, for a shop? Yes or no? Can you take this to do personalization of a website? Yes or no?
Yes, product recommendations அந்த மாதிரி ஒரு particular item recommendation for a particular user அந்த மாதிரி புதுசா ஒரு ஆள் வராருனாக்க based on this probably we can.
Yes. இதுல வந்து actually we already know those 671 people. So we need to have some information about the person.
For the new person, we need to have some information.
Some information, at least. Yes, one mail. It's called cold start there. That problem is called cold start. You know, it's an issue. We need to have some information. But there are ways to implicate some information. Fine. But remember, this is not user based. It's a content based or item based.
Got it.
Narna, Redia, Abhi, Srivaj, Prashant. Are you fine? Talk to me, please.
Okay, sir. Okay, sir.
Okay. Okay, all right. But I want you to think about why that some product comes there. Some product, same thing, some product, but because that's going to be part of the similarity measure. Okay. We still haven't done fully yet. We are just getting there. But that's a critical milestone in understanding. Okay. Now, calculate dot product. Calculate dot product. Okay. Row name genre 3. So convert. Calculate dot product. Convert to binary scale. Okay. Let's do this. Run. It's running. Done. Okay. Now, now we are ready to calculate the similarity matrix because it's a matrix. But before we do, let's understand something. This user profile shows for I in one of length result. If result is less than 0, you put it as 0, else result equal to 1. Okay. Convert to binary scale for I in 1 to length of result. What is length of result means, if you think? Length of result is 12,078. For result, okay, let's view the result. Okay, so this is 8. Okay, first, let's even find out what the dimensions are. So this is the result. Yeah, we talked about it. Result is the one we talked. In the end, I was trying to create the results, right? Results matrix. This one, right? the first user, second user, third user, column refers, and then first genre, second genre, third genre, and so on. 18 genres are there. So that's what this data is. I have created that data, results data, from here, which is already I set up the results matrix, and then I created the inner product. Convert to binary scale for I want to know. So wherever it is, results are less than 0, because there are minuses are there. You remember this inner product can result into some minus values. Everybody, do you agree? There are some minuses there, right? Binary ratings has minuses, 0, and pluses. +1, -1, 0. Three values are there. So this can be a negative values also. So we kind of standardize it to 0 versus 1. Okay, when it is negative, it is when it is negative, it's 0, otherwise it's 1. That's all I have done so far. So that's what you saw here in the results matrix. Now this is the final results matrix, what you got so far. Okay, and let's go to the. So in order to calculate the similarity measures, I'm going to use, there are many different similarities measures you can use, but I'm going to use this time Jacquard distance to measure the similarity between user profiles. So first of all, let me explain this one. In summary, what have we achieved so far? This user profile, that the results matrix, shows the aggregated inclination of each user towards movie genre. Do you agree on that first statement? This user profile shows the aggregated, that's what the inner product is, aggregated inclination of each user. We are only talking about for 671 users. Each user towards movie genre. Each column represents a unique user ID, and positive values show a preference towards a certain genre. The values were again simplified into a binary matrix. Positive values were mapped to 1 to represent likes, negative values were mapped to 0 to represent dislikes. Okay, because it will help me to do certain types of distance, similarity measures. Okay, some similarity measure we need. How similar somebody is, right? The 671 people order genre information based liking, disliking is what I have right now. Now I have to know who is most similar to the first user, for example, right? In order to do that, I need to calculate similarity measure. Everybody agrees with me?
Yes,
Correct? So far, so good. Enna Bala?
Yes.
Okay. Enna Prashant, Srivats, I am not hearing you.
Yes, sir.
Okay. Now that we have the user profiles, we can go two ways from here. Predict if a user likes an item based on item descriptions, movie genre. Okay, this can be done by predicting user movie ratings. That's what we are doing right now. Assume that the user likes similar items and retrieve movies that are closest in similarity to a user's profile, which represents a user's preference. Now, I use the second way that we decide to use Jacquard distance to measure the similarity between two user profiles. Okay, Jacquard refers to how common they are. It's a very simple measure. How common divided by the total number of measures for which the commonality is established. For example, set A and set B. The Jacquard measure is what is called whether the observation exists in A or B. That is what we take. Observation exists in A or B. So intersection of A intersection B divided by A union B. Okay, just make sure that is that's. Okay, so so Jacquard measure is intersection over unit. So how இப்போ நிறைய similarity இருந்துன்னு வச்சுங்க, நிறைய overlap ஆச்சுனாக்கா, then this is going to be huge, right? And it cannot be more than A union B. So it will be 1. For most similar rows of information or column of information, most similar information vector, this is going to be 1. Jacquard index is going to be 1. For less similarities, least similarity is going to be 0. Okay? Everybody understands what I'm saying? Yes or no?
Yes, sir.
Okay. Okay, excellent. Okay. Correcting Larna. Abhi. Okay. All right, so we are going to use that. So let's take the first user profile. That is the first column, is the first user profile. Because remember, 18 rows are genre, columns are the user related information. Okay, user related information. Look at this. 18 rows and 671 columns. Everybody? So I take the first user profile. Let's just take it as a vector. From the results 2, I take the first user profile, and then I take first genre profile. Okay, from the genre matrix. Just let's write it down like this. Now, for the first, now I'm going to do the because I'm going to create a for each person I need to do this similarity calculation. For each person I have to do the similarity calculation, right? So I take this first genre profile, okay, first genre profile, and I combine that with the genre matrix. What is the genre matrix? Genre matrix is what is the dimension of genre matrix? 3. So the genre matrix 3 is for every movie I have 18 maximum 18 types of genre information available for me for every movie. So for every movie I'm doing the or bind. That means I'm putting above this or below this. Maybe it's below. Okay, or bind. I'm binding for the with the genre matrix for 18 because I'm taking the first column. You remember in the results too. First column. How many? I mean, what is the dimension of result 2 user profile? Can you guess, somebody? What is the dimension of result 2 user profile? I'm sorry. Yeah, why is that 1? It is not there. It can. Oh, I can't probably say that. Just I will print it. That's better, right? Result 2 user profile. So it should be 18. On the other hand, genre should be the whole 671. Everybody understands what I'm trying to explain here? This is called the genre profile because given a genre, there must be 671 information bits given a genre, right? On the other hand, given a user, I will have 18 bits of information. Okay? That's what is done here. But what I'm trying to do is I add to the genre matrix, which is 9066 rows and 18 column. I'm adding one more. That is the I'm adding row bind, right? So we saw genre matrix 3 is 9066 by 18. I'm adding a genre profile. Genre profile is 671. I'm adding a genre liking to genre matrix on the top. That's what I'm doing by this. Let's just think very carefully here. I have a genre matrix 3 which is 9066 by 18, right? 9066 by 18. We already said that. And I'm adding to the on the top of that so that I can do the calculation with the top next one, with the top next to second row, with the top third row, and so on. I'm going to do that kind of calculation, through an lapply function. Okay, so it's a long vector of similarity values. Okay, that's what I'm going to do. Is it clear where I am going? Where I am going is I want to take each person's I want to take a genre profile information and then create what is the similarity index, similarity value of the genre for a particular person. So in order to do that, I'm going to show only one calculation. That is, take the first row of the genre profile, use that as part of this so that I can apply an lapply function within the matrix data frame to calculate that similarity values. இது கொஞ்சம் பாருங்க, do you understand this? I define user, everybody is quiet. Results profile is this one. Results profile is this. Results profile is user profile is 18 items, 18 bits, 18 numbers. Results genre is 671 numbers. Okay, so I'm adding that. Let's see. Now, what is the dimension of similarity data, similarity matrix? Everybody, are you with me? Why it should be only one added? Because I just added only one row.
The first one
Yes.
one you added, right?
First one I added. Remaining things were coming from the genre matrix 3. Exactly. Okay. Now I define because I need to calculate the Jacquard distance, right? In order to do that, I'm going to do an lapply function. Okay, list apply function for the simulator, this data set. Okay. And I'm just only doing it as converting it as integer for all the numbers, because I need to do, in order for Jacquard, I need to have a certain type of data. So I'm just doing that list apply, and that is calculated here. I did so far only up to this 3 gen. So I need to do this step also. Okay.
So genre profile 671 values in this list, sir.
Yes.
But அவ்வளோ values இப்ப நம்ம R-bind பண்ணினப்போ அந்த values எல்லாம் எங்க போச்சு? 18 9061 by 18 தான் எடுக்கறாங்க.
Okay. Let's see sim at first row. Okay. Sim at first. That is. It's just now. Let me finish this step and then let's talk. Okay. One moment. Okay, so results to user profile is, I think probably the way I have written is confusing, but let me, results to user profile, first user profile, that dimension is this, whatever results to user profile, user profile. I didn't do correctly. Okay. Result to user profile. This is result. Okay, first of all, dimension of result. How much is that? That is 18 by 671. 18 by 671. And so result to user profile should be 18. That's what I asked for, columns, right? Each column is 18 items. That's what this means, result. Using result, I take the first column, it becomes 18 items, 18 numbers. I take the result 1 comma, it should be 671. Okay. That is posted as genre profile. Your question is, that's what your question is. right? Genre profile. So I am doing OR bind. OR bind. What does row bind mean? First of all, before we go there, let me recall what is the genre matrix 3 dimensions are. It's 9066 rows and 18 columns. Okay. What does row bind mean? R bind means what? R bind naka, you are adding a row to an existing matrix. That's why sim matrix dimension will be, we talked about that, 9067. So I'm adding one row with 18 points, right? 18 numbers. I'm adding one row with 18 numbers. Result 2, genre profile, is what is being added to the genre matrix 3. Again, genre matrix 3 is 9066, 18. But result 2, your point is result 2, first user's genre liking is added to on the top. I think genre profile of the first user. Genre profile of the first user is genre profile first user. Put to genre profile. Comes out to be 671. Let me see what happens. I think it is probably, there's a mismatch there, 1, 3. I'm going to just write down this one, 0, 0, 1, 1, 1, 0, 0. Okay. If it is coming from here, 1, 1, 1, 0, 1, 0, 0, 1, 1, 1, okay. So, result 1 is genre matrix 3. Once again. Sim mat first row.
So is it add user profile here?
Huh?
Is it we should have added user profile?
Yeah. I'm going there. That is correct. There's a typo here. Yes. So yes, I had animation. Animation, children, comedy, drama, fantasy. This is not right. Okay, it should be. With the first movie, it should be fantasy, so it's not correct. Yeah, it should be result 2 user profile. Okay. In fact, logically, that will make sense also because this is the R problem. It didn't show any error because
Yes.
R does this kind of thing. It will cut it off or it will recycle. Okay.
Yes.
Okay. Thank you for that. Bala, are you with me?
Yes, sir. Yes,
Is
sir.
everybody with me?
Yeah.
Yes, sir.
Okay. Thank you very much.
Yes, sir.
Now everything else is okay now, right? I do the R bind now. It was not, the error was not very apparent before because, as I said, R does
Probably it recycled. Right?
yeah,
Recycled.
certain things it does. It will take whatever it needs and stop, or it will recycle depending upon whether there is more data or less data. Now I have a library called proxy, and from there I can use calling the method. I can call the distance matrix. I can create the distance matrix using method jacquard. Okay. It's still working. It's a huge calculation. Remember, this is an atomic, 41 million calculated numbers will be there because there are 9,067. The number of elements is 9,067 square minus 9,067 divided by 2. And that's what this number is. Okay. Is
Sir,
that
one question. Yesterday when we were starting to discuss recommendation engine, we were discussing something like cosine similarity of the right, sir. Why have we jacquard distance today?
What is the question? Why we didn't talk about jacquard? Is that what you're saying?
Yes, sir. Yesterday we were discussing cosine similarity to
Oh, right. Yeah, you can use, okay. Remember, there are many different distances. Now we are talking about how commonly, this particular genre information is liked. Commonly. There is a different phrase that is being used here this time. Okay. How commonly I like the action movies or fantasy movies, like that. There are different measures of distances. Jacquard is one of them. Cosine similarity is one of them. I did introduce you yesterday cosine similarity. There is also the Euclidean distance. A distance and similarity have, they are kind of dual information. Okay, the inverse of distance is a similarity. So there are different ones are there. Actually, I shared yesterday some different type, one reference which talks about those distances. I'm not sure. 1 second, please. So the question you might have is, why use this? Why not something else? I guess that is your question, right?
So, like, can't we use cosine similarity itself for today's calculations?
Oh, you want, your question is, can we use cosine method? Is that what you can use it? Maybe we should do that as a kind of, see this case study, it was published case study, so I took it and the author used Jacquard, and I bought into it. We can use it, there's nothing wrong, but maybe it's a good idea to check cosine similarity here, what happens, the results, okay? If that's what your question is. Okay?
Yes, I just wanted to understand, like, for a specific scenario, this is the distance we have to use. For other scenario, another similarity measure. Like that, do we have any standard? That's what I'm trying to ask.
Yeah, okay. So here, all information is coded into 0 or 1. When all information is coded into 0 or 1, the common question is, how many ones are there?
Okay.
Eventually, it will come down to how many ones are there. If it is a general multidimensional vector, numerical vector, general, income, age, distance from work, number of kids, and so on, you see all these things, I already said 4-dimensional data or maybe 5-dimensional data point, and it has points in all over, not just on 0 or 1 only, all over the whole space, right? Then the cosine similarity will be more useful.
Okay, sir.
Okay. So we have brought down everything to 0, 1, calculator. So you can question, why did we bring to 0, 1? We could have used, 1 to 5. The value is 1 to 5. If you remember, we could have used that too. Then it will be a different situation, and I would definitely say Jacquard will be of less use. Because we are not talking about commonness. Here, because of 0 and 1, commonness is more, is a key word there. Okay, so how many values are there in this sim results? This many values should be there. Everybody buys that? Let's see the head sim result. Maybe, I don't know. I'm just thinking it should show some values. Here it is. Okay, so 1.8857, 875, 1.875, and so on. Okay, and there must be let's see the length, or what is that? I think it should be length because it's another class. Sim mat. Sim mat. Sim results. Okay, sim results. Okay, that's why you get that many results. Everybody? Okay, and then I take the sim results of remember it's an atomic class. Okay, distance is an atomic class, and so many observations are there. And I said it is a matrix. Actually, it can be cast into a matrix of values because you take the first row and then you calculate all the distances with respect to Jacquard distance with respect to the 9,066 movies. You take the second row Okay, and then I can recalculate all these things again. So I can put it in a matrix form. That's why I know why do I separate out. Why do I subtract 9067? Because this is a diagonal size, and this data is only a similar. What is it called? What kind of matrix is that? It's a symmetric matrix, right? Because it's a distance, it's a symmetric matrix, and I don't need I don't need to store. This is a atomic class distance vector. I don't need to store the diagonals because they will always be 1, and then the one of the off diagonals I don't need, and so the remaining is what is this is 9067 square minus 9067 divided by 2. Okay. So far everybody is with me. We ask questions ourselves. Does this make sense? Does this make sense? And that's part of the story here. Why I wrote all this. Okay. Now, yes. I got. I take only the first 9066 values only, because that if I talk about the first person, those are the only numbers I need for the first person. Okay. So out of that, I'm going to take the minimum I should have. So I need to take the recommended movies for the first rater is the one that has the minimum Jacquard distance. Jacquard distance. I didn't call it as a Jacquard similarity. Okay, Jacquard distance. Okay. So I need to take the minimum values of the top minimum values only. Do you buy into it? What I'm saying?
Yes, sir.
Okay, good. So that's what the results are here, going to be given rows. So I do this calculation and then I select the movies list. So I have the rows number. These are the rows, which has actually there's only one row, right? I'm talking about the minimum most value, right? Minimum most value. Which row is that number? And then I throw that row, and then I find out it's the movie name. 2 refers to movies. In movies, what is the names of the column names, right? It's called names, or I think I can call it as names. See, title. I need the title of the movie. That's why I'm putting the second comma 2. And what row is the row 9123? That has the minimum most distance for the first person. Do you understand so far? And if I want all the rows, okay, I'm sorry, if I want all the information given a row, this is what it is, because I didn't put 2. If I put only, I will get the title. And this is the genre information, drama, mystery, and thriller. Okay. Drama, mystery, and thriller. Now let's go and see the first this one, give me a moment. Yeah. User results, user profile. Right. Let's see the what does this 111111 mean? Okay. So names maybe is still there. I'm not sure. I'll find out. No, I don't have names there. I don't have names there. Maybe names of the results too. Column names or row names. Dimension. Result 2. Results. Okay. So row names. I'm not getting the names. I need to find out, so that I can convince myself, does it make sense or not? Are you with me?
Yes, sir.
That's the reason why I'm trying to look for the name. So let's go back to one step, keep going back one step, and I will find that out.
Sir, here one doubt, sir. Sorry. The drama, mystery, thriller are only 3 genres that are showing up. But if we add the ones, I see about 6 ones there. I should be seeing 6 genres, is it not?
That is true, but the inner product, remember that the inner product is going to give, the minimum distance. Is Jacquard distance. It doesn't matter whatever the partial information, it is not there, it's going to be zeros, right? You remember? The remaining 18. Yeah. Genre 2, okay, here it is. No, not this one. Let me go back to some data set.
Column names of genre matrix 3. Will that be?
Column names, okay.
Matrix 3.
Okay, so what we are saying here is 1, 0, 3. This is 6, 7, 10, 11, 13, 14. 6, 7 is crime documentary. Okay. 6, 7 fantasy and film novel. 1, 2, 3, 4, 5, 6, 7 crime documentary, fantasy film novel, and then comes the musical and mystery. Okay. That's the time. That is the information column for this user profile. Okay. The question is, does it make sense? It's very important in analysis. We try to interpret the results, and does it make sense is very, very important. Okay, because that's what will help you convince others. So I said the guy for the first rater, we are talking about for the first rater. But remember, he said it's movie ID. Movie ID is this 7,625. So this is a row ID. I think it's a row ID. We want movie ID. Movie ID. Movie ID. Okay, so let me see. Movie IDs. Movies, and I want the second movie ID. That second is the movie name, where I have the movie ID to be. I want to say movie ID is 7,000, which is different. Remember, 7,000. It says that 7,625 is the movie ID. Okay. So how am I going to look at that? 7,625. 7,625 is movie ID. The recommended movies for the first rater is the one that have minimum Jacquard distance measure, which is movie ID 7625. 7625. I need to locate the 7625 in the movies. I need to locate the 7625. I can brutally look at it where the value is. Okay, where the value is. Movie ID is equal to 7625. Will this work? Another, I'm sorry?
The column name correct. Okay.
Yeah, movie ID is column name correct. I'm just not 9123. My earlier it gave me, oh yes, it did give me the same thing. 9123. Verbs Zulu. So I have a movie ID 7625, okay, and movie ID is 7625, but the row number is 9123. That's what it says. Because it came out to be exactly the same here also. When I said movie ID is equal to 7625, a truth table, and asked for the title, it came out to be the same thing. But there is also Girl 1998, 9123, Burbs, the 1989, Zulu 2013, all these things are coming. So the question I'm trying to answer is, I have a result and I want to make sure that, that is interpretable. Okay. And the result is that it says the minimum Jacquard distance is attained at, movie ID 7625. For the first user, we are only still talking about only one user. Okay. For that user, the first, minimum Jacquard distance is attained at 7625. And that movie turns out to be this 9123. But here it says prisoner, here it says girl. I don't know what is going on. What is this one? But I really need this one, which is Burbs. Is that what I have? 9123. Yes, Burbs. Okay. So, what would it take us to believe that this is working? I want to show that that movie, Prisoners is 2013. That's not what we are talking about. 8 movies rose. Prisoners. So if I say movie ID, the girl. 7625, movie ID is 7625, the movie name is The Girl. Okay, genre is drama, just the drama. And what is the first user profile? User profile is 111111. Okay, so, and we saw that 1111 is refers to R here. 6, 7, 8, 9, 10, 11. 6, 7, 10, 11. That is 6, 7, 10, 11. And the last one is 13, 14. 6, 7, 8, 9, 10, 11. 10, 11. He starts with that 10, 11, 6, 7, 8, 9, 10, 11, 12, 13, 14. 13, 14. So out of this, it is saying the drama is coming here, which has, out of this, all the movies which has the least distance is to this movie. That's what it says. This guy has all these properties, genre properties, documentary, drama, horror, musical, and and then romance and sci-fi. Okay, and it has the least distance to this one. You might be wondering, we still have to see more examples. So far, are you able to follow me what I have been trying to do and explain? It may not be coming perfect, but are you able to follow the steps that I have been looking at it?
Yes, sir.
It's not a perfect answer yet, I agree, but the other answer is even not so perfect than what we have now. That is the only way we can answer at this time. But the point is, we have to see more examples to see how good it is working. So that is where the goodness of fit comes in, right? Even for recommendation engine, we have to do the goodness of fit. So far, so good. At least do you see how I am thinking, how I am presenting it to you?
Yes.
Balavade. Okay, Prashant, Aruna.
Yes, sir.
When you think, I agree with you, okay? But I have to go around to explain how to interpret these results. Then the question is, does it make sense? Then the question is, on an average, how good this model is, needs to be resolved. So far, so good? How I kind of sequenced it? We need to look into that. Do you buy that? Do you agree?
Yes, sir.
Okay, good. So let's do some more work. Then you will see, because I'm going to talk to you about the I'm going to also talk to you about the user-based collaborative approach before I come to the the goodness of it. Okay, in the user-based collaborative filtering, we are going to use the cosine similarity. Okay, the user-based collaborative filtering, we are going to use cosine similarity, and then we will do the prediction, and we will check the goodness of evaluation scheme, goodness of it, with some kind of a cross validation. We take there are some methods that we have to follow. In this case, we are going to use good rating is what is meant by good rating, and then we will check how many times we need to do the cross validation and so on. Okay, so that is my purpose. In the end, that's what I want to share with you. That is, do a model, check whether it makes sense, but whether it makes sense is remember, one out of few out of checking few out of 100,000 or 10,000 is not going to be easy. It's going to be some boundary issues. Sometimes it may turn out to be cool, okay, but it's also possible that it doesn't give you enough information, because it's part of a bigger evaluation, goodness of it evaluation that you have to do. Okay, that's what I'm going to take you. But before that, I also want to do one more, because this recommender lab does a lot of work. I have done all these things to you from what is called from first principles. I have done all these things using first principles. But there is a software called package called recommender lab, and we can use the recommender lab to do all these things in one shot. Look at this one. Few results. We got the with a few lines we get the results. Library recommender lab. So in that case, I'm going to use, there are different methods they will give you. User-based collaborative filtering, that's what I'm going to use. Okay. And in that one, the method used is cosine similarity. Okay. Are you with me? There are some, very challenging, not easy to, buy into it easily. Things are happening there, but I'm explaining it to you. Don't lose heart, because this is how it happens. Some samples might not be really great. Some samples might be great, right, in the results. So you need to do overall goodness of it. That's our purpose. Are you with me? Yes. Okay. Not show all webcams. Yeah, we should see. Enna Bala, Durga, how is it going? Konjam kashtamā irukla to buy into. But this is something, if our regression model போடுறேன்னு வச்சுக்கோங்க, I just do a regression model, 10-point regression model. I do a 10-point regression model, and in that I select 1 point and then see how closely it is fitting into the line. Oh, it's not good. It's okay. It's kind of அப்படிலாம் சொல்றேன்னு வச்சுக்கோங்க. Does that validate the full approach to understand how good the model is? Definitely not. But I have to show few examples. So I picked up the first one and then try to show you how to interpret that results. But overall, we need to do the full goodness of model fit type calculation. Do you buy that, everybody? You have to do the full goodness of it. Anga regression line was the full goodness of it. What is the full goodness of it in regression? Somebody?
R square.
Adjusted R square, exactly. Right? That's how good it is also. That's first point. Second point is, in the Netflix problem also, in the movie prediction Netflix problem, in the competition, worldwide competition, the RMSE, okay, that is root mean square error, it was attaining 0.93 or some 92 or something like that. What Netflix was attaining, 0.9392. And the worldwide competition reduced it to 0.85. Not much difference, right? But that is considered as an achievement because the Netflix could not do it. Are you with me? Is my example. So you got to think on all these lines. My point is, I'm explaining it to you how to interpret the results, how to build it, how to interpret the results using first principles. So far, that's what I have done. Listen very carefully. Everybody, Bala, Prashant, Srivas, Aruna, Durga, and Abhi. Using first principles, how to build all these ideas in Kamche 2 hours. Okay, I have been walking you through how to think and then create the solution. Now, if I have a package, I would rather do that. Do you agree? Okay. Everybody agrees on that one? Okay, that's point one. Second point is, you need a break, right? Sorry, maybe you should take a break, 10 minutes now. I'll finish with this second point. Second point is, I show you some example points, whether how it fits into the interpretation. It may be good, it may not be good, it may be average. But nonetheless, you should look at the whole goodness of it of the model. With that, I want to stop, take a 10 minutes break, we'll come back and finish this. Okay, take a 10 minutes break. Let's finish.
Okay.
Are you with me, Bala?
Yes, sir.
Okay, cool. கொஞ்சம் கஷ்டம் தான் இதெல்லாம் வந்து we are learning for the first time how to think statistically. This is how to think statistically.
Right.
It's supposed to be part of BOSM, but anyway. நீங்க அப்பவே இந்த மாதிரி கன்சர்ன்ஸ் எல்லாம் வந்திருக்கணும். ஒரு சாம்பிள் எடுத்து 2 சாம்பிள் எடுத்துலாம் இன்டர்பிரட் பண்றீங்களா சார், எப்படி இதெல்லாம் பிலீவ் பண்ணலாம் அப்படிலாம் கேட்கணும் இல்லையா? என்ன அபி? நான் இது கேட்டா டக்குன்னு எஸ் சார் சொல்லுவீங்க. Are you convinced what I said is correct? Okay. Thank you very much. All right, take 10 minutes break. We are coming back and finishing it. Okay, with the goodness of it.
Okay.
And we will go through this if it needed, 2 times, and next time also we'll go through this. It's koncham kashtam, but it's very powerful method. And Netflix la vandu 0.92 enmo dhaan panna na sonnala, and they reduced only 5 points, 5 percentage points. 85 ku enmo vandanga avladhaan, adukku $1 million they gave, and it was a worldwide competition. Okay, all right, thank you. Let's take a break.
உங்களுக்கு யாராவது டெலிட் சாப்பிடா?
என்னோட
பெரிய இந்த மாதிரி பெரிய
ஏழுக்கா
முடிச்சா
Okay, welcome back. Is everybody here?
Sir?
Okay, welcome back. Is everybody here? Okay. All right, so what I wanted to share with you is I went through a long, lengthy process of how to think in recommendation engine. How to think in recommendation engine. However, as I said, there is a R package that is available that you can use to do your user-based recommendations or content-based recommendations. Okay, so I'm going to do, and also different type of distance measure you can use. So அது முன்னாடியே பண்ணிருக்கலாமே சார், எதுக்கு சார் இவ்வளவு வேலை பண்ணேன்னு கேட்கணும்னு தோணுதா? இப்படி தோணக்கூடாது, பட் தோணுதா?
இல்ல சார், ஸ்டெப் பை ஸ்டெப் உள்ள பேக்கேஜ்ல என்ன நடக்குதுன்னு தெரியணும் இல்ல சார்? அந்த பேக்கேஜ்
Exactly. Yes. In fact, the package does a lot more sophisticated stuff. I'm going to share with you. Okay. So, all right. First and foremost, we want to do some basic processing. Are you able to see my screen?
Yes, sir.
So basic processing. So I'm going to use reshape. Reshape 2 will give me the dcast functions and other things whatever I need. And I'm working on the original ratings data. I'm not talking about ratings 2 anymore. Okay, original ratings data. So I'm going back 1, 2, 3, 4, 5 type ratings. Okay. So it's done. And then I call the recommender lab. Ratings matrix is used as real rating matrix. I have to characterize that. That's a type of class, that knows how to handle sparse data, all those things. So ratings is defined as rating matrix is defined as rating matrix as real rating matrix. Okay, and then I normalize that, because what happens is when people rate, certain people may have a tendency to rate higher. Americans will always say, "Oh, this is great, wonderful," or they'll say, very bad thing, right? Lowest you can imagine. But Indians will not do that. Their variance in, the Indians rating variance is very small, and usually it's not on the positive side. Okay, but Americans are usually on the positive side, but it can get lower also. You get what I'm saying?
Yeah, it's a cultural thing.
It's a cultural thing. Because of that, you need to normalize it. That's what is happening, called normalize this rating matrix. Okay?
Agreed.
Cool. Let's run that one. And then I'm building the model. That's it. Create recommender model, user-based collaborative filtering. Now I'm using method is cosine. Remember that I didn't convert these ratings into 0, 1. That answers your question, Aruna. You recall that one? So why not cosine? Now we can use cosine. Okay. Once that is done, I got the recommendations. Prediction, use the function called prediction under recommender lab. Predict recommender model. That's the recommender model is recommender rating matrix normalized method UBCF. Parameter list takes cosine methods and nearest neighbor 30. So when we take an average estimate, we are going to take nearest 30 closest vectors, and then we take the average of that. That's what this means, nearest neighbor. Remember, we did nearest neighbor 3 in the U1 to U6 and I1 to I8, toy data. You remember that? Yes? Okay. So I'm ready. Once I build that model, I'm ready to predict the top 10. That's what this command is about, top 10. And find out that recommended list. So here, let's see, run this and see what those recommendations are coming out to be. Are you ready? Okay, there you go. It's done. Okay, recommended list is this. Okay, so obtain recommendations. I'm going to do run this. Recom list, recom result, and just call recom result. Let's see what happens. These are the top 10 recommended movies. Are you with me? Okay. Recommended movie, and we have easily obtained the top 10 for user 1. You see, this is recommended list for user 1. Are you with me? Looking at this, I'm picking up the movie numbers because 2 refers to what movie? Movies what does 2 refer to? Please. Column 2, right? Refers to the movie names. Okay, column 2 refers to movie names, and this is more recommended list. Recom list is coming from here. Recom list is convert recommender lab object to a readable list, and then I'm using that recom list to identify the movies and post it as recom result. Okay, so the recom result I got the recom result as these 10 movies. So just I have to look at the for example movies C colon 8672, right? I can find out those movies, right?
Movies, sir. Movie W.
Oh, movies. Okay. 8672, 3764, 84, 99. These are the top 3, for example. Let's just do this, huh? These are the top 3 movies that is recommended for the first user. It's documentary, adventure, action, and comedy. Okay, that's the kind of genre that is recommended by the user-based collaborative filter. I just picked up only the top 3 here. That's the movie ID. This is the row number. The question is this the movie ID or the result? The results is method goes in and okay, all right. Recommended list object readable one. Movies as integer recom list 1 I is equal to 1 recom list. Okay, so let's just read a little bit, understand more about recom list. So recom list is 608 4993 713 7153. These are movie IDs, remember that, okay? These are movie IDs and not a row number. And then I want to see one. I can pull out the 1, 2, 3, 4 about top 10 is this. Okay, these are the movie IDs. Now, did I say movie IDs correctly? I was looking for the rows here. Movie ID should be there. Okay, movies. Dollar movie ID. Yes. In. Can I use the word in? 608. Let's see what does it say. Unexpected movie ID is in. Movie ID. Movies. I'm sorry?
Square bracket $.
Oh, you mean you want this way? Yeah, let's see. Okay. Movie ID. But I want only this movie ID is equal to this. When the movie ID is, I want to know the whole row. Okay. So movies, how do I do that? Movies, first of all, what are the names of the movies? Okay, movie ID, title, genre. Okay, so movies. I thought it should work that movie ID is $movie ID, right? It should be a truth table. Truth table fed into the movies, and that's what we want, right? Movie ID equal to maybe this one 608. Okay, I'm going to do a brutal calculation. I'll go to movies. Movie ID 608. Let me just do this. Okay, 608 is comedy, crime, drama, thriller, Fargo. Okay. And 4993 is adventure and fantasy, Lord of the Rings. Okay. So that is the list of recommendations that is coming for the first individual, the top among the top 10 movies. These are the first two. Let's find out 5952. Let's find out 5952. Let's closer. Okay, 5952. 5952 is Lord of the Rings again. You guys, do you see that one? There is some similarities are going on, right? 5952 is again Lord of the Rings. 7153. Let's go to the 7153. 7153 is again Lord of the Rings. Wow.
Wow.
Okay. So it is capturing, the most similar likable movie for the first person adventure, and the genre is, we saw that, it is, not drama really, the adventure, fantasy, drama. Okay, adventure, fantasy, and drama. Okay, that is more assuring compared to what happened in the first attempt. Now. So we have done that one. So can we get some overall evaluation of the process? That's what I wanted to talk to you, right? I told you. So so what we are doing here is some kind of cross validation. You all know what is meant by cross validation. Did I tell you what is cross validation in PA1? Maybe I gave the notes, but I didn't explain to you. Cross validation refers to you split the data into as many number of splits you want. In this case, k is equal to 5. Okay, 5 splits of the data, the training data and the validation data you got, right? You split the validation data into 5 parts. So build in 4 parts and then test with 1. Again, build the remaining 4 parts and test with the second. Again, remaining 4 parts, test with the. So you have 5 models built. Are you with me?
Yes, sir.
And then here there are some special categories here. Because I already used 10 recommendations as a way of evaluating it. So what we are saying is first of all, good rating is considered as number 5. Okay. We want to know what is meant by a good rating. So case, good rating is number 5. We are still keeping 1, 2, 3, 4, 5. Okay. And the other thing is given is equal to 3 is another parameter you are use. Given 3 means out of selected 10, recommend 3. Okay. Out of selected 10, you are going to recommend only the top 3. Okay. Given 3 meaning out of selected 10, recommend 3. Right. And with that kind of condition, we want to see how good the evaluations are. And the method used is user-based, and we are going to try take one movie and see how good it is, given 3, how good it is, and then we take 3, once again. I have to explain that correctly. One moment, please. So let me do that and I will start explaining. Okay, recom results. We have done up to this, right? Recom results. Up to recom results we did. Recom results. Movies, recom result, yes. So let's do the evaluation and then do the print the evaluation results and interpret it. Okay. And it is running 5-fold. It is going to run 5-fold. So there must be 5 times stated what is happening with the results. Once it's done, twice it is doing. It's not bad. It's taking very less time. It's pretty good because you're taking a small sample of small subsets only. So third fold is being done. Fourth fold is being done now. And fifth fold is getting completed. Okay. And then once that is done, it prints the results for taking one movie and seeing how good it is, taking 3 movies and then 5, 10, 15, 20 movies. Okay. So always know we have these true positive, false negative, true negative, precision, recall, true positive rate, false positive rate. You know, these are known. I have taught about all these things. Am I right? Everybody? Everybody? So it's, you know, 1 out of 5. You can interpret it that way, right? The score, it is not 1 out of 5. The score it is giving is because it is, you know, because it is, you know, the value, the score values are 1 to 5. 5 is considered as a good, right? 5 is considered as, what is it called? 5 is considered as good rating. Okay, good rating. 5 is considered as good rating. So, precision, you know, let's take a precision, okay, true positive precision. Okay, whenever it is correctly identified, when it is correctly identified, you know, true positive means something that is, you know, positive. You know, so we say that it is true and we identify it as true. That is true positive. Whenever it is, you know, true but we identify it is not true, that is called false negative. Whenever it is positive, whenever it is not positive but we say it as positive, it is false positive. Whenever it is not true and we say it is not true, we predict as not true, that is true negative. Okay. So you know, consider these columns only right now. Okay, these are all numbers between 0 and 1. Okay, these are all numbers between 0 and 1. And the precision is that, you know, 23% of the time, you know, we are able to identify true positive and true negative. It's very low, isn't it? But as I said, remember, even in Netflix competition, the Netflix achieved 92. You know, the RMSE root mean square error was 0.92 or something like that, 0.93, 0.95, something, 0.93, let's say. And the competition achieved only 5% increase. You know, the root mean square went down to 0.88 or 85, something like that. Okay, 5 from 93 to 88, something like that. So you shouldn't be worried that, you know, it is, you know, too bad. You know, it's not that great. But the thing is, you know, in terms of ranking, if you do it any other way, you can't even get this. So, என்னப்பா இது வந்து மோசத்திலேயே least மோசமா எடுத்துக்கலாமா அப்படின்றப்ப தான் இருக்கு இல்லையா? That's because you see, remember, the variance matters a lot. You know, how much variance you have in the data is going to determine how good your model is. So 20%, 23% of the time when you have one move comparison, you achieve 23%. It is, you know, ranging in that range to 10 to 20%, 10 to 20%. As you increase, it doesn't really improve because the variance is too bad. And as you increase the number of evaluations, you know, it doesn't increase the results too good. It's range, and there is a lot of variance also here. That's all I can say. But what happens is, as you increase, what is the recall? Recall is the average of. Can somebody tell me what is the recall? Average of. So it's an interview question.
True positive divided by false negative plus true positive.
I'm sorry, true positive?
Divided by false negative plus true positive.
False negative, right? Did you say false negative?
The false negative plus true positive.
Yeah, true positive and false negative. It's a harmonic average. Harmonic mean of true positive and false negative, right?
Yes, sir.
Okay. So recall is getting better. See, you have to use some specific type of measures. You have to use the right measure at the right time. Oftentimes recall is also used because recall matters, not the precision. So recall is looking good. True positive rate is looking good. So it's reasonably good recommendation results. That's all I can tell you. Are you with me? We will go through this. We will go through this one more time. Come back. There are some issues that I have to explain here. The notes are not that great, so I will have to articulate it in my own way. Okay. The notes have the recommended lab notes is not fully explaining everything. I should share that with you. Recommended lab. This is the one I use here. Maybe here. Package. 40 pages. This is what I use. Okay. And actually uses all these functions. Before I close it, I just want to share some information with you. Yeah, so that's exactly what I was trying to show you, okay? But this is a different data set. It's a different data set, so we will go through this one more time because it's somewhat the documentation itself is not that easy to use. So we should go through this one more time. We have enough time, no worries, okay? But what I want to impress on you is that full model evaluation is important. Cross-validation is oftentimes used because it is a classification here, good rating versus not good rating. 5 is good rating in this case. And so it becomes as a classification problem. That's why it's a confusion matrix is needed here. And then there are different measures, as you all know, true positive, false negative, true negative, precision recall, TPR and FPR, false positive rate, true positive rate. All these things are useful information, but the thing is, we have to know how to interpret it correctly. Any other method is not going to solve you the problem. That is, so you have what you have here. It may look like it is improving only 5% on 10%. That's the problem. You see, in engineering, that's not an issue. When you are doing image identification, for example, it's 90%. 95%, 99%, accuracy, right? That is not the case in behavioral models. This is a common issue you will face in your interview also. Oh, is that all you can do? 10% extra, but in real life, in behavioral model, that's what you will get because the variance is too much. Am I making sense? And that's the kind of conversation you have to be very comfortable with. Bala, correct?
கரெக்ட் சார். அதாவது அந்த இதுல சொன்ன மாதிரி டேட்டாவை மிஞ்சி அதுல இருந்து டேட்டா எடுக்க முடியாது. என்ன டேட்டா இருக்கோ அதுல இருந்து தான் ஸ்டடி பண்ண முடியும்.
Very interesting the way you said it. Yes. So there is some more. One more time, I want to revisit this. We will go through this one more time. You also read yourself the materials I give you, and I can give you this this link also. I'll post it in your chat here, in the chat. We will go through this one more time, and with that, recommendation engine will be completed. The question is, how comfortable are you to use recommendation engine? You may feel that, no, sir, konjam kashthama da irukku, believe pandra pola illum varaliye appdinu thonum. Even regression modeling and the problem irukku, remember that, okay? You may not know that I am very vehemently articulating all these points, so it may look like you will easily buy into not getting good results. But that's not the case. Okay, don't give up on that. It's very, very difficult compared to simple linear regression. Where am I going? I want to show you that regression is a problem. Okay, just let me open and share with you. Regression is the problem. So don't think that it is all kind of loosey goosey. Some people will say like that, loosey goosey, right? It's not. Are you with me?
Sir.
So let me go back to this point. Here it is, right? So had I taken here this point, the error is quite a bit here compared to this point. It so happened that whatever I took as the first example may not be right. Okay. So are you folks with me?
Sir.
Okay. Energy left. You're all kind of not very excited.
Yes.
Yes, sir. No, it is good. The method, in fact, what I would recommend is, because it's a difficult idea, and part of the other problem is I went through how to think in recommendation engine. I spent a lot of time, 2 hours on doing the transformation, decasting, calculating the ratings matrix, inner product, calculating the distance. All those things are done by recommender lab very easily for you, right? This is better, yeah.
Yes,
Yes,
sir.
sir.
The way we went through is better. Okay, I think so. So let's continue to dig deeper. Next class also I will go through this material one more time, and hopefully by that time you will feel very comfortable. Okay, and I encourage you to do a recommendation engine job project for your capstone. Ready?
Okay, sir.
நீங்க பண்றீங்களா capstone? இல்ல. Are you doing full course? You are not doing full course.
No, sir.
No. இவங்க பண்றாங்க.
Yes, sir.
Yeah, so they will have capstone projects. Okay. Fine. Okay. You are doing a full course?
Yes, sir.
Okay, so you will do. I really recommend, because there is so much. It's probably easier to do clustering, but recommendation engine is a lot more powerful, I think. With clustering, you will have segmentation methods, which is very important for strategizing your operations in a business context. Okay, with that I close today's topic, but next week we will talk one more time on recommender lab. Okay, I want to assure you that you should feel comfortable to create a solution. Thank you.
Thank you, sir.
Bye-bye. Any questions before I go?
Sir, you have the updated notes on Jacquard index.
Anyway?
Hello, sir. And the PA2 notes extra ஏதாவது போட்டிருந்தீங்களா Jacquard index அது அனுப்பிடுறீங்களா?
Oh, you mean distances?
Jacquard.
அதுல இருக்குமே, பாக்குறேன் நான்.
230 slides இருக்கு.
235 இருக்கா? ஒரு நிமிஷம். அப்புறம், so what is the question?
இல்ல 258 slides இருக்கு, updated நினைக்கிறேன்.
ஆமா, correct. Yeah, so don't download anything. Just click on it, watch it, read it, learn. Just leave it, because you should always use the latest for various reasons. I might correct something, I might add something, I might rearrange something, I might drop something. So latest notes எப்பவுமே அந்த link மட்டும் யூஸ் பண்ணீங்க. Don't download it. You don't need that, because even after 2 years you can come back and use the notes, but that might be updated with new notes. Okay.
Yes.
Okay. Did I answer?
Closing question. Before that, sorry. Yeah, just a closing question. Is the cosine கொடுக்கிறதுக்கு பதிலா அந்த UBCF filterல cosine க்கு பதிலா நான் இந்த Jacquard distance கொடுத்திருந்தாலும் இதே ரிசல்ட் தான் வந்திருக்கும் இல்லையா?
I don't know. You will have to look into that. See, the reason why cosine is, we didn't change that into binary values. That's what she asked. Aruna asked. You remember? Yes, right. Under what condition you can do Jacquard on what condition? I said, because there are binary ratings, it is what you need is overlap numbers. I know I have to look into that also, the idea that good rating will define sort of where it impacts. But the point is, it didn't change it. Largely speaking, it didn't change the ratings.
Right.
But it changed the rate. We changed the ratings in when I did the work from first principles. Okay. But because it is recommended lab is there, you can always quickly do some variations of it and then solve the problem. Here is the distances. I would like everybody to go through this, right? This is the distance reference, right? Prashant?
Yes, sir.
This is the one you are talking about. Yeah. So I think maybe we should play with the recommended lab a little bit more and make yourself more comfortable. And you don't have to do all those foundational calculations that we did. Don't worry, no worries at all, right? Just do the work using recommended lab and create the recommendations and compare, make sense. And where does the confusion matrix fits in? Remember, when you have 100,000 or let's say 600, 700 people information, 10% of that is 60, 5% of that is 30. That might be a very lousy recommendation. Who knows? But most likely it won't be lousy. It won't be totally lousy. It may be least connected, but not totally lousy. Lousy, no, opposite of one. Adirkadu. Right? You buy into it.
Yeah. At least the trend will be maintained. Exactly. Accuracy might go for a toss, but the trend will be maintained.
Yes, exactly. Correct. And Abhi and Durga correctla. Okay, no problem. So let's meet next time. One more time, we will go through recommendation engine. I really encourage you to do recommendation engine for your capstone. ரெண்டு பேரும் ஒரே ப்ராஜெக்ட் பண்ணீங்களா ஒருத்தர் ஒவ்வொரு ப்ராஜெக்ட் பண்ணீங்களா கேக்கல ஓ ஐம் சாரி ஓகே டாக்
புரியல சார் நீங்க என்ன சார் கேட்டீங்க
ஓகே இல்ல உங்களோட கேப்ஸ்டோன் ப்ராஜெக்ட்டுக்கு ரெக்கமெண்டேஷன் என்ஜின் பண்ணுங்க
ஓகே சார்
my question is your project class
ரெண்டு பேரும் தனித்தனியாவே பண்றோம் சார் சேர்ந்தே பண்ணல
okay good all right thank you very much all good night
thank you sir
thank you கேக்குறா என்ன சொன்னீங்க பாலா
சார் இன்னைக்கு ரெக்கார்டட் செஷன் அப்லோட் பண்ணிடுறீங்களா
No, it is recorded. So when I close it, I will finish and then I will post it today.
Yeah, sure, sir.
Bye.
Bye, sir.
Bye, sir.
Have a great day.